Hello everyone. Now that we have small number of students in the course, we are going to do this in online course. So what I'm going to do, I'm going to uh, post a video lecture bi-weekly, every other week, and you are going to watch the video and take note and try to do the project or homework that I'm going to also show you at the end of the video lecture. All right. So the topic that I'm going to discuss now is about organizing data, right? So last week we talked about different techniques and different um, things that we have to consider when we are gathering data. And this week we are going to talk about how we actually going to organize once we gather data, right? So we're going to talk about um, categorical variable and numerical variable, right? Um, and also we're going to talk about how to construct and interpret what's called the frequency table and the relative frequency table. And once we construct that table, we're going to talk about how to actually construct frequency bar graph and relative frequency bar graph. And we're going to also talk about how to interpret this bar graph as well. So let's talk about categorical variable first. Well, categorical variable is also known as qualitative variable. Consists of name or label of group of individual. So categorical variable means the variable that we are dealing with is non-number form. Non-number form. So what could be a non-number form or qualitative variable? Just like your name or nationality or eye color or your major. All those things are not number, right? Your eye color is not number. Your major, what you're studying, different students study different major. These are non-number. Your nationality is non-number either. So all those non-number type of variable is called categorical variable. Now, what about those number form, which is numerical variable? Well, numerical variable is also called quantitative variable. Now, we talked about this last lecture, but just to remind you that quantitative variable means it's going to be a number. So consists of measure of quantity that describe individual. So what could be a quantitative type of variable? Let's say our height, right? That's a number. Someone's salary, money, that's a number. Distance from school to your house, that's number. What else can be a number form? Well, a weight of a textbook, different types of textbook, that's number form. So all those type of variable is what's called the numerical variable, which is the number form of the variable. So let's try to identify whether this variable is categorical or numerical. Let's talk about the age of person at a hip-hop concert. Age of person. Is age a number? Yes, age is number. So the variable age is going to be numerical variable. What about academic major of a community college students? Academic major is non-number form, right? Well, different community college student has a different major, like business major, psychology major, and so forth. So it's going to be categorical, non-number form. All right. What about the maximum speed of car, right? Miles per hour. Well, speed is also a number form, right? Speed is a number. So if it's a number form, that's going to be numerical variable or quantitative variable. What about, zip code of home in Alaska or Arkansas, right? Um, Zip code of a house. Well, zip code identify a group of homes, and that's going to be a categorical. Now, this is particularly confusing because most of zip code is number, right? But that number, different zip code, that number doesn't really have a numerical value, right? For example, if someone's zip code is 2000 and someone else's zip code is 1000, that doesn't mean that it's twice of that value of different zip code, right? Those 1000, zip code 1000, zip code 2000, it's just a different, it's just referring to different area, not necessarily that number means twice of the other number, right? That's why this is an exception. Even though it looks like a number, this is going to be a categorical, right? Now, what about this? A variable consists of zeros and one, where zero stand for man, one stand for woman. Now, this is another example similar to the zip code example. So, if one for man, one for woman and zero for man, is that really representing number? No, it's number that representing whether it's male or female, man or woman. So that zero here, that one here, it doesn't really have the numeric value. It's just a representation of different types of human, right? Man and woman. So this is also considered as categorical, right? So this, well, let's say this and this is a little bit confusing, but that's an exception. It's a number, but doesn't really have a numeric value, right? All right. And let me just remind you that while you are listening this video lecture, if you have any questions, you can actually ask me. You know what? Since it doesn't have the slide number, let me actually include slide number for everything. Slide number applied to all. Just try it again. Now, there you go. Now you can see that slide number right there, right? So if you have any question about this particular page, you can always email me and refer to this slide number right there, right? So if you have a question in page 5 about the maximum speed of car being numerical, then you can email me about this, right? All right, let's go to the next slide. So this is about how to organize a categorical data. What's categorical data? Not usually non-number form, right? We had a two exceptional case with the zip code and all that, but usually it's a non-number form, and we're gonna build um, a table from this data. Now let's talk about this data. Now, as you can guess, this data representing different types of movie that they like. So how many data points are there? We have 1, 2, 3, 4, 5, 6, 7 columns. We have 1, 2, 3, 4, 5, 6. So we have 7 by 6. We have 42 different data points, right? We have 42 different data points. Now, so I guess it's just like you went around the campus and asked people what type of movie that they like, and for example, out of 42, 1, 2, 3, 4, 5 of them says they like drama, right? And as you can see, some of them says they like comedy, someone else says they like action movie, and some others said thriller and horror movie and so forth, right? So I guess our next question is, how do we organize this data? How do we organize it? I mean, you know, this is just a bunch of different movie types, and how do we, what's the best way of organizing, as the title suggests, how to organize this categorical type of data? Well, one of the way of organizing this type of data is to put it in a table, right? And that table is called the frequency table. Now, as you can guess, we have different categories for different types of movies. So we had, drama, action, thriller, comedy, horror, others, and we have 6 different types of movie that we see in here, right? Now, once you figure out how many different type of categories that we have, you put them in the first column and you call that um, um, different categories. Now, then you go back to this original data and you probably start from the first item, first data, and moving either this directions or this direction, and checking in how many of each type of movie that we have within the data. So the first drama right there, if you have the drama there, then you put, this is tally, which is just a counting device. So you put 1 bar right there. And that first bar right there actually came from this. Then you move to the next, you have comedy. So, the comedy section, then you have another 1 bar right there, right? See, this is group of 5, right? That's how you counting in tally. This is the counting technique. Then you go for next next data, which is action. So you find the action and you put 1 bar there, and you check the next one, which is drama. So you get another line there, right? So you go through all this movie one by one, checking how many different types of movies that we have. So, and you counting using the tally technique, counting technique. So drama, you have 1, 2, 3, 4, and one diagonal means it's complete the group of 5, right? So we have 5. What about action? Well, actions right here, we have 1, 2, 3, 4, 5, and we have one more, so it's gotta be 6. And thriller, we have 1, 2, 3, 4, right? When all this, we have 4 thriller. So we have one here, one there, another one there, another one. So we have 4 of them, right? So we get 4, and comedy and horror and other and so forth. So we have all this frequency here. Now, if you add all the frequency, oops, then as you can see here, we have 42, which is the total of all those data points. Now, this is what's called frequency table, right? I mean, look at the table here. If you really think about this, you can, once you put it in the table, you can see right away that we have the highest concentration in comedy, which is like 16 out of 42. And I guess the least popular would be thriller. We only have 4 of them out of 42. And I guess the action movie and the other type is a tie because they are all 6. And drama and horror movie is also tie as 5 and 5 there. So, you know, looking at this data, I mean, you can see all the data, but you really, you can't really see the general trend and then what's really popular. I mean, you can kind of see comedy many times, but, rather than that, it's not that easy to see. Once you put it in the table called frequency table, then it looks like this, which is a lot easier to see, organize, than just organizing this raw data, right? It's a lot easier to see the general trend and what's popular and all that. Now, we also have what's called the relative frequency table. Now, this is frequency table and this is relative frequency table because we have this relative frequency columns. So, we have this part is exactly the same. That part is exactly the same as the previous table. Now that we have, for example, drama was 5, frequency of 5 out of 42. Well, 5 out of 42, how many percent is that? Answering that question is what's called the relative frequency. So 5 out of 42, if you just type it in your calculator, you have 0.119, which is about 11.9%, right? This is how you convert this in percent, right? 0.119 means 11.9%. What about this most popular from the comedy? 16 out of 42. So 16 out of 42, that's 38.1%, right? And so forth. So what it really does, the relative frequency table, what it really does is just convert frequency into a percent, which is the relative frequency. Now, so if you add all the frequency, if you add all this, then you're supposed to get 1. But that wiggly line right there in each of this is not exactly an equal sign. This is approximation sign. That calculation right there doesn't really end 0.119. It actually goes on, a fair bit, but they cut it right here. So because you cut it in a third decimal point place, then you are going to end up having what's called the round off error, right? Because you round it up, it may not be 1 when you add all that. You may get like a little bit more than 1, or sometimes you get a little bit less than 1, right? It's not unusual to get that. So once we get this into a table form like this, right? This was the original data. Now we have this table form on page 8. Then not only that you see the frequency, but now you see this in proportion. So you know that comedy about 38.1%, right? About 38%, let's say, likes comedy type of movie, right? And for example, 11.9%, or you can say 12%, right? Approximately 12% likes horror movie, and so forth, right? Okay. I mean, compared to this, that gives you a lot more information, right, than this original raw data. So once you get that, now you want to graph this table, and that's what's called frequency bar graph, right? Frequency bar graph. And we're going to talk about the relative frequency bar graph soon. So this graph, you just converting this frequency of different types of movie into a graph. For example, we know that drama, we had frequency of 5, and comedy, for example, we have frequency of 16. So in drama goes up to frequency of 5, comedy goes up to frequency of 16. You can see that it went up to 16 and so forth. So, table is nice, but graph, it's somehow it's even easier to figure out the general trend and everything else, right? It's easier to figure it out, the general trend and everything else. So graph is also a very effective tool to present the data. So, in your project or the homework, let's say you have this raw data. What you're going to do, you're going to build the frequency table just like this, figuring out how many different types, put it in the category, and count one by one, get the tally, and count the tally to get the frequency. Once you get the frequency, then put it in that form, right? Each frequency divided by the total, get the relative frequency. Once you do that, then you build this table called frequency bar graph. Well, if you take a look at this x-axis, it just gives you the scale, the unit scale of the frequency, right? From 0 to 5 and 10 and 15 and 20. So that's actually from category with the frequency column. Now what about if we match the category with the relative frequency column? For example, drama matching to 0.119, and that becomes this graph. So drama was 0.119%, right? Well, not percent in decimal, so it's 11.9%. And this is what used to be frequency axis, the y-axis, usual y-axis. Now we have the relative frequency there. Then it goes, the drama was 11.9, comedy is 0.381, right? Little less than 40%, right? So this table you can also get from this table, matching the category with relative frequency column, right? That's this table. So not only you see which one's highest and the general trend and everything, you know in proportion, right? 38% liked comedy and 11.9% liked the horror movie and stuff, right? Okay, now as for the project, right? As for the project, what you can do, gather 30 data of favorite part of Nile College from students, and you can ask this question to the student whether they like Boone Center or the gymnasium or the library or Schumann Hall or Simpson Hall or other places. So we have 1, 2, 3, 4, 5, 6 different choices, right? So if this is like an in-class course, I was going to give you guys about 20 minutes to go out and gather 30 data points, asking 30 different students, and what's your favorite place, what's your favorite building, so to speak, in our college. And once you gather that data of 30 students, and then make the frequency and relative frequency table, just like this table here, right? This category is going to be different building. Once you get the data, you can count them. Then you can set up the frequency column. Once you set up the frequency column, then set up the relative frequency column. So that's frequency table and relative frequency table. Once you set up that table, now I also want you to make two graphs. One's called this bar graph for frequency. So it looks like this, right? The actual frequency goes here, different types of building, right? The library, the Schumann Hall, the Boone Center, it goes all here. And I also want you to make the relative frequency bar graph. So, something like this. So this column right here, now you are going to use the relative frequency, and this column right here that you are going to use drama, the different types of building, right? And that's the project. So by not next week, which is 29th of October, but by the following week, which is October 6th, right? So you have 2 weeks to try this project. So you can ask 30 students, ask this question, and give me 2 tables, right? Frequency tables and relative frequency table, and give me 2 graphs, one bar graph and one relative frequency. Bar graph for frequency and bar graph for relative frequency. Give me two graphs. What you can do, you can try this and draw the table on your note, and you can take a picture or scan it, and you can put it in the Dropbox that I'm going to set up, right? So you can put that in the Dropbox before the October 6th, right? Before October 6th. Now, so, if you have to gather 30 data from Naya College student, get this, and set up this 2 table and 2 graph. Now, we also have a homework. This one, you don't have to collect the data. Data is already here, right? This is different types of music that people or student like. So we have 1, 2, 3, 4, 5 columns. We have 1, 2, 3, 4, 5, 6. So here we also have 30 data points. Now you are going to do the same thing, right? Just like your project. So make a frequency and relative frequency table. You can put it in one table like this if you want to, and then do the two different types of graph for frequency and relative frequency, just like this or this. So this is also due in October 6th, before October 6th. So again, I'm going to set up a Dropbox, and Dropbox, you can either do it in the note and take a picture, or scan it and put it in the Dropbox. If you have any question or trouble putting in the Dropbox before the due date, please let me know by email. Then I'll try to answer you those questions, right? Okay. Please check your email regularly so that we can do this online course without much problem. Alright, and don't forget to email me if you have any type of question regarding the course or this lecture. Alright, take care. Bye.